Today you're going to review a lot of the vocabulary that you need to know for our next unit on solving equations. So before you can solve an equation, we need to know the basic vocabulary that comes with any algebra problem. So the first thing we have on our note sheet is this algebraic expression. The algebraic expression often contains a variable, which is a letter that represents an unknown value. So what we're going to do when we write in these notes is we're also going to color code in the example, so we know that yes, this is the variable in the algebraic expression and that's the letter. The next thing we need to know about algebraic expressions is that a coefficient is the number right next to the variable. So that means this coefficient of 5 means there are 5 x's, or 5 times the value of x. So the word coefficient is important to know, so color code that also with your highlighters. You can use any 3 color highlighters. You don't have to use the same color I'm using. And the last term that you need to know is that we often have a constant in an algebraic expression. The constant in this case is a positive 8. So constant is the number by itself. It has no variable to get multiplied against. We just either add it or subtract it from another term in the algebraic expression. So the next thing you're going to see in your note sheet is this expression here. And this goes over the idea that we have different terms or parts of an expression that are often added together. And if you don't see a plus sign, know that you can do your keep, change to change that subtraction sign into a plus sign. So really, terms are separated by plus signs or minus signs. So as a quick reminder, we have variables in this problem. In this case, we have the variable y and we have the variable z. We have coefficients in front of those variables. We have a coefficient of 6 in front of this term, and we have a coefficient of 8 in front of this term. And then your constants, as you can see, I've highlighted those because we often, when we're looking at an algebraic expression, we don't want it to take up as much space as this one has. So to rewrite this expression, you could say that there are 6 y's plus 8 z's, but we can combine those constant terms because they're just plain numbers. Negative 2 added to 4 gives us positive 2. So this would be called a simplified version of that expression. It has the same value, it just looks a little different because we added together those constant terms. The next thing on your note sheet is to remember what like terms are. Like terms are terms with the same variable. Remember, that's the letter. You're also going to see some examples that are raised to different powers or exponents. Okay, this example doesn't show that, but I'll make sure I give you another one that does. We need to often simplify an expression like we talked about in the last example, so we make sure we combine like terms. So sometimes doing that with a highlighter is very helpful, like I've highlighted the m's, 4 m's, and then I did my keep, change, so I remember this is a negative 2m. That gives you 2 m's. And then we could take a different highlighter to color the next one in. We always work in alphabetical order, so that's why I did the m's first. And then you can focus on these n's. If you don't have a highlighter for the questions that we're going to practice later, you could always underline and then maybe like circle. All right, anything to visually separate the values from one another. So this is where I got my 3n because we really have a negative 3n plus 6n. And then finally, if you want to put a box around your constant terms, we have our positive 9 plus our positive 7, giving you this positive 16. So this expression right here is much more simple than this one was. We've combined all the like terms that get added. So again, those are variables that have the same power that we combine together. You're never going to want to add your m's to your n's or your constant terms to your variables. They want to stay separate because remember they mean different things. So in an algebraic expression we need to leave them separate. So we get 3 terms from this example. Now the other piece of your note sheet is going to review distributive property with you. Distributive property is allowing you to multiply each term that's on the inside of your parentheses by this number, usually it's a number, sometimes when you get to high school it'll be an actual letter term, but by the number that's on the outside of the parentheses. So I always put a raised dot in my problem to remind myself, oh yeah, I got to multiply. 3 times x is just 3 x's. And then 3 times positive 5 gives us positive 15. For your second example, you probably want to do the keep, change back here so you don't forget that that's really a negative 3. But in the very beginning, we would take this negative 4 times 2y to get negative 8y's. And then be careful, negative 4 times negative 3 is really positive 12. So we have to be very careful with our negatives when we're multiplying. And then here's another example of combining like terms. You'll see the term simplify often, which means see if there's like terms so you can add them together. And then make sure you do that using integer rules. Okay, so one of the big integer rules from last year is remembering that this is really a negative 8 because you can keep, change when there's any subtraction. The other terms we're going to leave alone because we know that those are already positive values. Okay, so I would start out, if we go in alphabetical order here, I would start out with the y's. So I'm just going to underline my 7y plus my 3y. That combines to give us 4y's. And then I think what I'll do is I'll circle the next letter that I have in here, which is z. A lot of students mess this one up because they see the 6 z's and they don't think there's another z here, but there really is. This is almost like we have a 1 that they didn't bother writing in. They're talking about 1z, whatever that stands for, so we need to make sure we add that into the 6 z's that are over here. And then finally, again, we talked about not having to use a highlighter all the time. If you just want to put a box around your constant terms of 5 plus negative 8 are going to give you negative 3. The other proper way of writing this is to keep my 4y plus 7z. But then we could just use a plain old minus sign. Okay, that minus sign, remember, is the same thing as adding a negative 3. And finally, down at the bottom, we get to a little more challenging question because this example that they want us to simplify has parentheses. And remember what we talked about at the very beginning? If you have parentheses, it means you need to use your distributive property. So we are going to start out by distributing this 3. 3 times a is definitely 3a, and it's positive, so we'll put our little plus sign. This 4 back here is really negative if we do our keep, change. So 3 times negative 4, we can write it as a minus sign 12. We could also change that to be a plus negative 12 if we really want to. And we may do that because now we realize we have like terms. We have some a's to add together, so 8, 9, 10, 11 a's. And then back here, we've got some constant terms. So we've got to combine our positive 2 with our negative 12. So we should end up with this nice 2-part answer. You know that sometimes you'll get a 3-part answer. Very rarely will we get a 1-part answer, but it is possible. And that just depends on how many different variables and constant terms that we have. So now what you need to do is tape this into your notebook neatly so that it is complete. And then what you're going to begin is this practice sheet where you're going to practice combining like terms. You're also going to practice distributive property. And then check in with me for a way to check your answers when you're finished.